it'll be it's pretty useful to learn. So to start, I can tell you a bit about myself. On a personal level, I'm always on Spotify, and I love to hike. I graduated from UNC Chapel Hill 2 years ago with computer science. So my friends actually got me into CS, and that was probably my favorite reason for it. And I ended up TAing for Dan Pazewski for Comp 101, and I really enjoyed like teaching computer science and learning about it as well. And funny enough, one of the other TAs that I used to work with called me up and he's like, "Hey, I just got this job at this company. You're gonna like it." I remember, when I started looking for jobs, the main thing that I was concerned about was, not doing the same thing every day in and day out. So he's like, "This is a consulting firm. They have a lot of different clients. It's part of your job to like know what's cutting edge in the industry and know how to apply it." So I think that really extends to Docker. And from my own experience, just traditionally going in front end and then learning some back end, and just now being a full stack developer and still making strides to being a better full stack developer. I think containerization is huge, especially as we think about like microservices and just how it expands. But we'll unpack some of that later. So what is Docker? I know some of y'all have probably heard of it. Some of you might have even had some experience with it. So it's a tool to package software into containers so that they can reliably run in any environment, right? And that sounds very pretty when you say it like that. But what does it really mean? So like when you think about development in modern day life, there's like a bunch of different languages. There's a bunch of legacy systems. There's like all these integrations and interactions between our code and our data, right? So we have to start thinking about, how this works, and how to manage that workflow and how best to manage that workflow, because a lot of these things are things that keep growing with time. So Docker helps do this by like essentially giving developers the freedom to like pick whatever tool you want. And this is super valuable, especially when you're thinking about microservices, because there are some companies out there who can really master what they do. But then there's all sorts of other external factors. There's licensing. There's just a bunch of other stuff. But when you think of a tool like Docker, it really lets you manage that interaction, right? So you can say, AWS is great for this, and this tool works great on there. How are we going to make that interaction work with our data here? And we have, MySQL Server all the way over here, But not only that, it takes that a step further, really, because it makes things highly, highly accessible. And we'll again unpack that as we go. Another thing to consider are like CI/CD like pipelines. So I mean that's just another example for like another use case, but like realistically, these pipelines are like huge in the industry, and it's just continuous integration, continuous development and delivery. And we start to realize that like this is kind of a living system, and it's almost like your code almost becomes like surgery, right? Like it's something it's running all the time, and we get to go in there and edit it. So having the ability to go in there and define what we want is huge, especially involving a bunch of different microservices. So I talked a little bit about like versioning. So this is like the main problem that people love to hate, and that Docker really solves. So it's known as like the works on my machine problem. I hope none of you have encountered this, although probably you have. You download you download whatever like you're using, whatever you're basing your app on, and maybe it's a version of Node that's like really old, and maybe there's like some functionality in there that you really want, but when you send that application that you wrote over to your friend and he tries to run it on his machine or her machine or their machine, and it doesn't work, they know like that there's like some discrepancies there, right? So there's a whole bunch of different dependencies that our apps have, and depending on like what versions and what other factors we need in order to get our code to run right. So Docker lets you write something known as a Docker file, and these files, they really just like let developers recreate whatever sort of environment like they need in order to get their application to run, right? Traditionally, these sort of dependencies are like just listed. If you're lucky enough, they're listed in the documentation of whatever app you're working in. But it can be kind of a headache to like go in there and like read all of that. So the fact that you can just look at a Docker file and like see or even list out the dependencies that you need is pretty significant. So with Docker, it lets you sort of package whatever application you have, send it to somebody else, and they can open it on another machine and run the file, which will recreate the environment, and it will run exactly as intended. So you can imagine that's super valuable. And like my own personal experience, like there's multiple different ways to like package an application. You can use like a virtual machine, for example, but it like has a bunch of extra like resources that can make it kind of clunky to use. And even just myself, like working with like banks, for example, like you might get your VM, but you still have to wait to get permission to download this because it's all tied down, and it's nothing that was like predefined in the environment. So that's pretty awesome. This is just like a really short like copy. Well, it's just an image of a Docker file, but it's really just meant to explain how it works. Just give me 1 second. And we're going to leave the presentation for just a sec, so we can just jump into the documentation. That's really the best place to look for something like this. Cool. So this is the main structure of a Docker file. So you have like from, copy, run, and your command line. So here's what each of these does. So from really just instantiates like your base image. And here, I want to make sure we cover that before I go too far down that rabbit hole. But essentially, what you need to know is that these are like the blueprints to create your application, right? So this grabs your main image, and you can sort of define the environment as you go along. But really, just keep in mind that this is like a blueprint to create an image. And here we're going to get into what each of those are. So an image is like, the best way to think about it is like your application at a specific moment in time. So they're completely read-only, which means you can use one image to make a bunch of different containers, and that can be very valuable in and of itself. Especially when you're thinking about like the ability to mass produce something is all like it's all there. So let me see. Yeah. So like from an image, you can actually run it and make a container. A container is like the actual living, breathing, process that is running with your code and your data and what have you, whatever your application is actually running. So these are very compact in comparison to like a virtual machine. And we'll get into some of that architecture in a few slides. But this is really, these are the main elements that you want to focus on, are Docker files, images, and containers. And you're going to want to get as comfortable as possible with those. So you can, you have a Docker file and you can build it, and that's actually the command. And then once you have your image, you run it and it makes a container. And, don't let this like scare you. An easy way to like think about it, at least what helped me, was like almost like you're cooking, right? So a Docker file is pretty much like the list of ingredients that you need to like make like cookies, for example. And then your Docker image is almost like a little cookie cutter. You can have a billion different types of cookies depending on what cutter you have, right? So you can define your image, right? And then your container is the best part. It's the cookie, So once you have it running and it's made, it's already been predefined with all the right ingredients. So if you want to share some recipes, go right ahead. So these are just some more reasons why people really like Docker. Um, it's very flexible. The fact that it allows like very, very complex applications to be Dockerized is pretty awesome. And the fact that, you can tie in like a bunch of existing things, package it, modify it to however you want it, and then deploy it. It's pretty awesome. So they're lightweight, especially in comparison to VMs. VMs are like, I currently work in one day in and out, and it's not the most fun thing. It can just take a while. They're very clunky. Um, so portability is the next one. This one's a big one. Docker actually has an entire Docker hub with very big community. Docker really exploded in the last 5 years. It's by no means the only containerization service, but it's definitely a favorite. And I would encourage y'all to try it out, and then try out the different ones too, and see whatever works for your hacks. But in terms of portability, you can actually you can not only define your images and run your containers, but you can upload your images directly to the cloud, and then from any machine, log in, pull it down. Actually, not even log in. Like, well, as long as you're logged into Docker Hub, but there's a bunch of other repertoires for images. You can like pull down images from wherever you are, really, and then just run them on whatever machine you're on. So whether I'm on like my crappy, Lenovo T440 from college, I can still, pull down something that I made like my current machine, right? Which is awesome. Like, I've had friends, just coming through and they're like, "Oh, look what I made," and no matter where we are, they can pull it down, which is pretty cool. It's the advantage of cloud, right? So loosely coupled, this one's huge, especially when we're thinking about like scalability. Docker works with a bunch of stuff, but one thing it can really work with is like Kubernetes or Swarm. So that really, really lets you like, and I'm kind of speaking like loosely coupled and scalable right there, but it really lets you scale horizontally. Let's say you for your project, you have like a hack that was intended for like 20 users, right? And you're going along, and then all of a sudden somebody posts it on Reddit and it explodes, and all of a sudden there's like 20,000 users. So you can use Kubernetes to help you scale that, but the best part of that is that you already have your predefined image, and they're like very easy to replace. So if there's a user who's on a container and something crashes or goes wrong, that like you can take it down and replace the container and like have the experience be like much better. And secure, like you can really, really define like the environment in order to like, and accessibility, right? As you go in, and that one's pretty big, because like, let's say you're developing something that you want to scale horizontally, but it's only like a very small part of like your application, but you have to scale it horizontally because maybe that small part of your application needs to be scaled 20,000 times, but the rest of it doesn't. It lets you do that. It lets you isolate whatever part of your application you want, and really use those images. So here we have a bit more of the sort of like structure between Docker and virtual machines. So this was like the old way to, and I mean, it's still common, maybe a little bit too common, but it's the old way to like package code, right? And you can see here the guest operating system, it like mimics the hardware and like the OS, right? So like you have your app here, but each one has this like main operating system, right? And here on the left, if you look at Docker, you have each of these containers running on Docker, but there's one main host operating system. So in other words, like all of these containers are running on the same kernel, which speeds up the process a lot, so that's a pretty good, representation on there. So we can get started, and I'm keeping this kind of informal, but the main thing I want to show y'all is Docker Hub is a big one. So you can log into Docker Hub and like they have different like levels depending on like licenses if you want to like, you know, have more space in your repository or make certain things public or private. But like this is really like this was based on GitHub. So the idea here is like you can upload and download any image that you want, you know. So there's already a bunch of like base images that you can look at. We can explore here. Cool. So like these are all base images, right? So let's say your hack involves Java and you want Java in your container, you know. There it is. It's Docker certified. This is like from the publisher. And so there's a bunch here. There's like Ubuntu, Redis, you know, it just really keeps on going. So there's all these like different microservices and images here that we can, you know, sort of start to integrate. But on top of that, there's also like a bunch of images. So like these are all official images from these companies. And there's also unofficial ones too. For example, there's this one, very, very basic one on GitHub actually. So the nice thing here is that, you know, we have our little README and whatever, but it tells us here a very simple application for Docker, just build and run. And this is how you access your test, right? So if we were to look at the run file here, you see this is Docker build T. So this little T just defines like your tag, so your name for that instance or container. And then really here, we're just sending a message that says hello, right? And then we are exposing it here to port 8080, right? So if we were to go, let's open up our terminal here. Let's clear this. So the first step would be to clone that repository if we're pulling it from GitHub, which, you know, we've already done. So we know that's there. And then you're going to want to navigate to where that Docker file is, and then run our Docker run command. So I will actually click here. And I really recommend, sorry, I have my images there. I'm going to put this back, I promise. I recommend going to just like Docker cheat sheet when you're getting started. Honestly, it's super efficient. Like you'll have these memorized in no time. But essentially here, it's just like really easy to tell you like, you know, how to build, how to run your applications. And there's like the same thing if you want, like, if you're confused about what's going on at any point, you can just do Docker, the actual command, and then -- help, and it'll come up. So we see here, we're running it now that we have our image. And it says go simple app server starter. And I'm going to back up for a second. When you're working in Docker, probably the most important command you'll use is Docker ps, or ps, whatever. I've heard that before. Sorry, bad joke. So you can do Docker ps. Lists out all the ones that are closed, right? So this will pull up all of your running containers. So these are all the containers I've ran that are still currently on my machine, right? It's possible to get rid of these as well. But if you were to do Docker images, those are all the images that I have. And again, you can, you know, like that node one, if you wanted to get rid of that, you would just do Docker RMI because it's an image. And then you can either do just node, you know, based on that name, or just the image ID. So really the image ID is just more of the fail-safe way to do it. So it deleted it. And then we can see there, it's gone, right? So now we know that, you know, that we can like have images and containers in our terminal. But really, if you're trying to pull something from the online, which this is really where the magic happens. So there's this way to do it. Like I mentioned before, that you can just copy that repository if you're on GitHub. But let's say if you want to pull something just directly from Docker Hub, you can just we'll pull down a Ubuntu. How about that? Docker Hub here. Here's Ubuntu, Linux operating system based. So the great thing about Docker Hub here is there's like all these references. So there's literally like, this is how you can define like what version you want to pull in. So, if this is like on a Docker file to make this image, like that right there is where you can define what version you want to pull in. So here it is, Docker pull Ubuntu. And I'll copy it here. Paste, there it is. And it will pull it in. You can see here, it already existed on my machine, but it will literally pull it in from the cloud. And then one sec. Actually, sorry, I got ahead of myself there. So we can see here, like, once you pull this down from GitHub, sorry. Once you pull this down from GitHub, here, like, once you run it, you can actually just like use this curl function to like pull it up in your local app. So if you look at what we did before, this long one. Okay, so here we are running our application here, and it's just like, this is the message that's going to pop up once it's running. And here we're exposing it to port 80 on our local machine, right? So we'll run this guy, and it says Go Simple App Server started, right? So what does this mean? This means that our container is currently running. And we can verify this if we go to another tab, and if we go to Docker PS, and whereas we didn't have it running before, there it is. And this is what we define our image to be. This is the port it's opened on, and just like our basic like status on our program, right? So let's say we were to kill this guy. If we were to do the same command of Docker PS, you see it's not running there anymore. So what if you're like, oh wait, I had something running, but I forget what it was called or whatever. You do -A, and that'll open up like all the axed containers. Another way to do it is with this this little GUI right here. So Docker actually provides a Docker desktop, which really like helps if you don't want to work in the command line all the time, although you'll probably get used to it, and it's probably the way you want to go. But if you're doing like little things, like if you're starting and stopping something all the time, this is just easy. It lists it all out for you. So if we were running our old guy, cool. So if we were still running this guy, we would see it here now. There it is. It's running. And if we wanted to open this in the browser, it'll take you to the port that you already opened it at. And here we can see our message, hello. That's pretty neat. And then I wanted to show you all this. This is a really good resource if you're just trying to like learn Docker, especially like as you're considering what you're going to do for your hack. This really is great to like learn. If you want to deploy your first Docker container, run a static HTML website as a container. It just keeps on going. And these scenarios, it's pretty nice. It does it in like its own little environment. So here we'll like do what we kind of did already, but deploy a static HTML website as a container. So you can just start your scenario, and it gives you this neat little terminal here to play around in, and it kind of walks you through like how to do it. So like create your Docker file, right? So here, this is like what we talked about, right? So from Nginx and Alpine. So this is pulling in the most recent version of Nginx and Alpine, right? So and then it'll copy that into our directory. So I'll throw it here. We'll click continue, and we can start to like build our Docker image. So there, we'll run that. And if you wanted to list it now, there it is. But it was just that web server image that we just put in through. So we know it's this one. And if you see here, there's like a :v1. That's known as a tag. That's like great for versioning. So like you can see version 1 or whatever. So very similar to like how you would do something in like GitHub or like with a commit or something, Our branches if you're using that like to version, you can run here. So this will actually run the image. There it is. And then we have that curl function again, so we can actually see and verify how that ran. And this is another very simple one. It just says hello world, but there it is. So I would really recommend this site. It's Katacoda. And then really just like the best way to learn Docker is just really to like use it. So I would really encourage y'all to just start thinking about how you're going to like package your hacks. And, especially if you want to make something that can reach a bunch of users, I really recommend looking into like images and containers and seeing how you can package that and make everything like accessible. So here there's a bunch of self-guided tutorials, it's pretty awesome stuff. So with that, I am going to stop presenting, but I'm open to questions. Cool. Let's open up Discord. So does anyone have any questions? Anwar, I don't know if I'm missing any in the chat there. Cool. How do you see the folder structure inside the Docker? So, that's actually a good question. So you can actually open up the container, and it's almost going to look like JSON, and just kind of give you like either like a YAML file or something that will like give you each of what is in your container. Very good question. And it really also depends if you're like where you're hosting it. I know some like I know Google has a bunch of images available. There's some on GitHub, like how you saw that sort of walk you through each of the files and just like the building and all that. Can you detail any projects you? So I actually don't have like a ton of experience with Docker. I've studied it on like a personal level. I have a lot of friends that love it. I'm on my third client now. Oh, and by the way, the questions don't have to be specifically about Docker or containerization. Just like feel free to shoot with any sort of question. But I'm on my third client now doing Salesforce development. So um, it's been quite an experience. Just like working with all sorts of like different clients, whether financial or commerce or what have you. But specifically when you're thinking about like microservices and just like as a consultant, it's like my job to know what the best tool for something is and how to make those things work together, right? So when you're thinking about like let's say maybe your client really wants to use this microservice and like that you want to build something out and that functionality is not supported with whatever the client wants. This would be a way to do that integration and do it in a way that like you have maximum control over it in a way that also would work on whatever machine you need it to. So you're asking because you want to using a Docker file to copy your app to Docker, but want to check if it worked. So if you again, if you want to make sure that it worked, you can do Docker PS to like see what running containers you have, and like otherwise you can also do images. But like I just know that Docker and containerization is something that's really growing in the industry right now. We have more and more clients that are taking an interest to it, especially like when you start thinking about like you know if you want to reach like thousands and thousands of users, you have to do it in a way that's not going to be clunky and flexible. You know, feel free to shoot with more questions. I'm trying to keep this kind of informal. Any last questions? Cool. One last thing I might do is just like one last like roll through of just pulling something in. So if we did like Docker pull Ubuntu, so we have the latest for that. So now we want to do Docker run Ubuntu. Okay, sorry, I'm getting some errors. No worries. But yeah, I would just recommend taking a look at those resources. There's a bunch of There's a bunch of really good stuff that'll just walk you through it. Yeah, so Jay's completely right about that. You can mount and shell into your container volume directly while it's running locally. Well, cool. Well, I can make myself available if there are any additional questions after this. Sounds good, y'all. Well, I hope that was helpful. I hope this will make y'all think about how you want to package your hacks. I'm excited to see what y'all come up with. Um, yeah, go Heels, y'all.